students, my name is Madam Sheila Chogo. I do teach chemistry at Light Academy Secondary School. Today we are going to look at chemistry paper 3. It's a practical paper. Chemistry paper 3 actually carries close to 40 marks and it has about 4 questions. Each question may run up to 10 or 12 marks depending on the weight of the concept that has been tested by the examiner. So when you look at chemistry paper 3, there is what we call qualitative. We have qualitative and quantitative analysis. So we have qualitative and quantitative analysis. Now, these are the main areas that are focused on in chemistry paper 3. So quantitative analysis involves actually measurements of the quantities of a particular constituent that are in a substance that is being tested. For example, you are given a solid, and then you are given maybe chemical reagents, and you are told to carry out titration. You may be expected also to carry out different tests depending on the topic that is being tested. So for quantitative analysis, the students needs to observe the following. First, the student needs to measure exactly what has been asked. So there is need for accuracy. The student needs to be very accurate in giving his measurement and even in using the apparatus he's using. For example, if it is using the thermometer, you need to know how to measure the thermometer at the temperature on the thermometer. If it is using the burette, the learner needs to know how to measure exact volume that is required for that test. And in quantitative analysis also, we have the student may need to draw a graph. There are also graphs in quantitative analysis. Now, for the graphs, there are several aspects the learner needs to know. One, the graph should be well labeled. It should be well labeled. That means both the y and the x-axis should be labeled. If this is the graph the learner is drawing, for example, this is the y-axis, and this is the x-axis. If he's drawing a graph of volume against temperature, then the volume may be written here. So the volume is written in cubic centimeters. The units needs to be given and shown in brackets, failure to which the learner is deducted half a mark. And then the y-axis, if it is temperature, the learner should show that that is temperature, which is being measured in degrees Celsius, or the units that have been given in the exam question paper. So the axes must be well labeled for the learner to score, and then when drawing the graph, the learner should be careful. If it is a curve, it should be a smooth curve. If it is a line graph, it should be a straight graph. Another thing the learner should be observe under quantitative analysis is that when he's carrying out titration, he uses the values he has got in the practical to calculate certain quantities of the substances that have been asked. Maybe he's required to get moles of a certain quantity, or molarity, or the mass. So when doing out calculations, the learner should always have a logical flow of the calculations and use the correct formulae. Failure to which the learner may be deducted marks if the correct formula is not used. And also, as the learner is carrying out the calculations, he needs to make sure that the units given are correct. And then, when it comes to titration, specifically, when it comes to titration, still under quantitative analysis, there's the learner needs to draw maybe a table. The table is given, and then the learner needs to fill the titer values. Now, as the learner is filling the titer values, there are certain rules which should be observed when filling the table. One, the learner should always make sure the table is filled to the correct decimal place. Normally we use 1 decimal place. So the learner should fill the table with correct decimal place. For example, if is carrying out a titration of 3 values, so if this is the table, this is the first titer value, this is the second titer value, this is the third titer value, and the first value he got 20.2, the decimal should be observed throughout the table. If he fails to write the decimal in the second titer value, for example, if the learner just writes like that, there is a point he's going to lose a mark. So the decimal should be observed throughout. So if this is 0.0, 0.0, 0.0, these are readings from the burette. So the volume, titer volume will be that. This one will be 20.0, and then this one will be 20.0. Yeah, so that is one rule should be observed when carrying out titration and filling the table. Now, when the learner is now averaging the values for the titer values, there is need for the learner to use consistent values. So if the values have a range of, the values should be having a range of plus or minus 0.2. If the values are out of that bracket, then the learner should use the ones which are close. Maybe if the first two are close within that bracket, then the learner should use that. If you realize your third value is quite out of the bracket, this bracket, then it is not advisable for the learner to use that. Otherwise, use this accuracy range when calculating average volume used for the titration. So for quantitative analysis, we are not going to look much into it today. Our main discussion today is basically quantitative analysis and qualitative analysis. So when it comes to qualitative analysis, it refers to the process of carrying out chemical tests on substances with the sole aim of identifying them. And this is achieved through close and careful observations that are reasonable, and conclusions are based on these observations. So the learner may be given solids. Maybe you are given a certain solid and you're supposed to identify what that substance is. So through carrying out tests on that solid, finally the learner will be able to tell exactly what chemical compound or what cation or what anion is present in that solid. And then when it comes to qualitative analysis, we can carry out qualitative analysis of inorganic substances or qualitative analysis of organic substances. Now, first of all, when it comes to inorganic substances, basically these are salts that are being tested. So in organic analysis, the learner has to know the following. One, the learner needs to obtain good results. So in view of this, first the learner must first of all accurately identify the various test reagents. So the learner might be given reagents. For example, if you're given this is sodium hydroxide, the learner needs to look at the reagent carefully and read the labels to know which chemical reagent is given, so that he may also predict which kind of test he's going to carry out. And then identify what these reagents test, and then predict the expected results. That is important too. And then some of the important points the learner needs to know is that formation of precipitates may lead to identification of cations. Cations are basically positively charged ions in solution. So, so when a precipitate forms, it means when you're carrying out a chemical test and a precipitate is formed, it means there's a certain cation that is present that is giving that result. 1, 2, evolution of gases leads to identification of anions. So if he's carrying out a test, maybe he's been given a certain solid and he's added a reagent and there's evolution of a certain gas, or he sees colorless fumes coming out, or fumes which have a certain color, then automatically the substance being tested is an anion, a negatively charged ion. And then the learner should also know that Testing for the presence of cations involves the use of dilute sodium hydroxide or aqueous ammonia as the preliminary test reagents. So when you are testing cations in solution, so it's basically sodium hydroxide and ammonium hydroxide that is normally used. Yeah, so ammonium hydroxide and sodium hydroxide are used when testing out for cations in solution. That means in most cases, metal ions that are present in that solution. And then identification of anions involves the use of dilute hydrochloric acid, sulfuric 6 acid, or nitric 5 acid as the preliminary test reagents. So if still the learner is carrying out going on with the analysis, and then he's been given sulfuric 6 acid, or he sees a reagent that is labeled nitric 5 acid, or a reagent that is labeled hydrochloric acid, basically inorganic acids, then the learner should have the idea that it is an anion, a negatively charged ion that is being tested for. So, and then some concepts the learner needs to know are basic tests for gaseous products. For example, if he's carrying out a test on a certain gas, he needs to know first of all the color of the gas. It's very important. Now, when it comes to colors, it stems right from the theory that has been learned. So certain gases have different colors. So for example, if we look at some of the few gases the learner has come across since Form 1, you realize that in Form 1, the learner encountered hydrogen gas. Now, this gas is just a colorless gas. So, as the learner is carrying out a test that involves hydrogen gas, you don't expect to see a certain color, but only a colorless gas. So, this one is colorless. Now, it's normally a big problem when it comes to stating the observation, because most learners now will go ahead and say a colorless gas is observed. So, the question is, how do you see a colorless gas? It's very difficult. So instead of saying a colorless gas is observed, the best response should be fumes, gas bubbles are observed, or the learner can talk of effervescence, because a colorless gas may not be seen. Now, when it comes to the other gas that has been encountered in Form 1, that is oxygen gas. Oxygen gas has also been learned in Form 1. So this one is still a colorless gas, so there's no expectation of a certain color. And then when it comes to Form 2, the learner came across as gases like carbon 4 oxide gas, carbon 2 oxide gas. So still these ones are colorless gases. When it comes to Form 3, the learner came across gases like ammonia gas, gases like nitrogen 4 oxide gas, gases like nitrogen 2 oxide gas, and sulfur 4 oxide gas. So the nitrogen 4 oxide gas is the one which has a characteristic color, which is brown. So whenever the learner sees brown fumes, then he knows automatically that is an indication that nitrogen 4 oxide gas is present. And then, so the color is very, very important. Color of the gases is very, very important. But the one that stands out actually is nitrogen 4 oxide gas because of the brown fumes. And then the smell also can give an identity of the gas that is being looked for. For example, if you look at all these gases, most of them do not have a particular odor, save for ammonia, which will have a pungent smell. In fact, it's an irritating one. And then nitrogen 4 oxide, which will also have a pungent smell that is choking. And then chlorine gas will also have a pungent smell, and sulfur 4 oxide. So such gases can be easily noted from their smell. So if the learner is carrying out a test and he smells of a smell that is irritating or that is choking, then automatically he can guess maybe that is sulfur 4 oxide gas, maybe that is chlorine gas, maybe that is ammonia gas, or that is nitrogen 4 oxide gas. And then the learner can also identify the gases by looking at their effects on moist litmus papers. So there is a reason as to why the litmus paper has to be moist, because if the litmus paper is dry, it may not easily show when the learner is testing. So the litmus paper must be moist first so that the gas can dissolve in the moisture before now giving the particular test that is required for the paper. So if it is a basic gas like ammonia, the basic gas that has been learned so far, this one will change red litmus paper to blue. And then if it is an acidic gas like nitrogen 4 oxide, automatically we expect it to change the blue litmus paper to red. So using a litmus paper, the learner can also tell the identity of a gas. But always remember, the litmus paper must be moist. If it is not moist, it may not be easy. And then, as the learner is testing for the gas, it is advisable for the learner to just introduce the gas, the litmus paper at the mouth or at the mouth of the jar which contains the gas. Don't dip the litmus paper into the container because it may interact with the solutions, change the litmus paper without necessarily testing for the fumes being produced. And then there is also need to look at this action on lime water. That is, if a gas is being produced and the learner doesn't know what is the gas that is being produced, but he has been asked to tell the identity, then action on lime water will automatically tell the learner that that is carbon 4 oxide that is being produced. So carbon 4 oxide basically use lime water, which is calcium hydroxide. And then another fact is that the learner can also test the gas that is being produced by using a glowing or burning splint. A glowing or burning splint. Some learners confuse here because there are two gases that have been learned so far that we use either a glowing or a burning splint. So for the burning splint, the gas that is used is normally hydrogen gas. So for this one here, we use a burning splint. So for hydrogen, a burning splint is used, and the result should be that if the gas is supposed to be there, or it's expected that the substance is producing hydrogen gas, then automatically the splint will go off with a pop sound. This one will go off with a pop sound. Learners should be careful not to say a popping sound, because I've seen some of my students saying that. So it is not correct to say popping sound. Instead, the learner should mention of a pop sound. Now, for a glowing splint, the only gas the learner can test is oxygen gas. So for oxygen gas, the learner can use a glowing splint. The learner can use a glowing splint when testing for the presence of oxygen gas. So what is the expected results if oxygen gas is there? If oxygen gas is there, then the glowing splint will rekindle. That means it will burn again, it will rekindle. It will light up again. Because it was glowing initially, now it is going to rekindle. So those are some of the aspects that can be considered when carrying out identity of certain gases. And then sometimes it's necessary for the learner to have background information on certain concepts that are being tested, because all that is being done practically has been learned theoretically. So unless the learner has built knowledge over the years on this theoretical knowledge, it is very difficult to integrate now the practical approach and the theoretical approach. So having some background information on the concepts and the topics that have been learned, it's quite necessary. For example, a topic that is most critical, or a topic that the learner should be aware of, it's salts, basically solubility of salts. It applies everywhere, both in theory and even in the practical. Because when it comes to the practical, the learner is going to test for maybe the cations that we've been talking about, the anions that we've been talking about. But before the learner knows about these cations and anions, he needs to know whether this substance is soluble in water maybe, or it's not soluble in water. So solubility of salts, it's actually quite mandatory. So when it comes to this background information on salts, of course, up to now, up to this level, the candidate should be knowing that all nitrates are soluble in water, irrespective of which metal. All nitrates are soluble in water. And then all chlorides are soluble in water, save for silver chloride, that is not soluble completely. And then lead 2 chloride can only dissolve on warming. Otherwise, it cannot dissolve in cold water. And even mercury chloride, of which we don't have it in our labs. And then the other thing is that all carbonates are insoluble in water except carbonates of group 1 elements, that is sodium, potassium, and carbonate. And then ammonium carbonate is also soluble in water. Otherwise, the rest of the carbonates are not soluble in water. And then the learner should also know that all sulfates are soluble in water, except sulfates of lead, sulfates of barium, sulfates of calcium that dissolve sparingly. That means they dissolve partially in water. So calcium sulfate, you don't expect it to dissolve completely in water, but just partially. And then all sulfites are insoluble in water except ammonium and alkali metal sulfites. And then apart from barium sulfate, which dissolves on addition of nitric 5 acid or on addition of hydrochloric acid. And then some of the information the learner needs to know is about the effects of heat on salts. So because this is quite necessary, because there are certain tests the learner may be given and is told to heat a solid and then carry out tests to identify the products that have been produced. So without knowing this, it may be difficult for the learner to identify what is being produced. So if you look at nitrates, for example, most of them decompose, but now the decomposition depends on the position of the metal in the reactivity series, the metal in the reactivity series. So for example, if you look at nitrates of potassium and sodium, they are very stable, highly stable. So when they are heated, they only decompose slightly to release oxygen gas. They only yield a little amount of oxygen gas to produce the nitrite and oxygen gas. And then, now when it comes to the middle metals like calcium, metals like magnesium, metals like aluminium, zinc, lead, iron, and copper, these ones, when they decompose, they produce the metal oxide, and then they produce also nitrogen 4 oxide and oxygen. So the metals that are quite lower in the reactivity series, metals like silver nitrate and mercury nitrate, when they decompose, they only release the metal itself, nitrogen 4 oxide and oxygen gas, because they are quite unstable. So when you heat silver nitrate, you expect to get silver metal itself, nitrogen 4 oxide and oxygen gas. There is one particular nitrate the learner should be aware of, that is ammonium nitrate. When it is heated, this one now, it will decompose to produce nitrogen 1 oxide and water. Its decomposition is not similar to the nitrates we've looked, it decomposes differently. So apart from the other nitrates, ammonium nitrate should be given special attention. So those are some of the ideas the learner should be having before now majoring into the practical or now starting to do the paper 3.